Hello, I'm Kostas Gourgouliatos from the University of Patras, and I'm going to discuss double neutron star magnetosphere interaction and its implications for FRBs. First, we consider a model problem of a pulsar embedded within a uniform field. We find that the current sheet has a finite size in this case, and the field lines that are linked to the pulsar are confined by these separatrix. We next solved this problem numerically, and we found that for the case of an aligned pulsar with an external magnetic field, as the external field increases, first the open flux increases, and also the separatrix moves closer to the pulsar. If we consider then a counteraligned external field with the pulsar dipole field, we notice that we can obtain the same type of solutions because the equilibrium here depends on the magnetic field pressure that scales with B squared. Nevertheless, we can have different types of solutions in the form of a Danji sphere. Next, we consider how these solutions can be applicable to double neutron stars, where one member is a strongly magnetized neutron star and the other one is a millisecond pulsar. We find that it's possible to have the case of linked magnetospheres, where field lines from pulsar A are linked to the field lines of pulsar B. We can have cases of wind interaction, where pulsar wind from A interacts with the magnetosphere of pulsar B. And we can have also Danji type magnetosphere, as in this case here. Depending now on the magnetic field orientation, we can have transition between the linked magnetosphere or a Danji type magnetosphere. It's interesting to notice the transition between such states can release energies of up to 10 to the 40 ergs per second that puts them in the FRB range. Considering now the galactic double neutron stars, we notice that they currently are in the weak interaction regime because they are far away from each other. Nevertheless, a few tens or probably hundreds years prior to their merger, they can go in the strong interaction regime. And in this case, they may oscillate between the linked magnetosphere or the Danji type magnetosphere. In this case, they can release large amounts of energies. In summary, we have found that embedding a pulsar in an external magnetic field drastically modifies its magnetosphere. Most double neutron stars will spend several millions of years of weak interaction. However, it's likely that during their last hundreds of years, the interaction enters the strong regime. In this case, both the spin down power changes, but they can also fluctuate between different solutions. Now, as the system transitions between these different solutions, we can have the formation and the disruption of current sheets, and this could be related to the release of energies of up to 10 to the 40 ergs per second, putting them in the FRB range. Thank you very much for your attention.